Yes, class. Am I audible to all of you?
Yes, ma'am.
See, so in the last class, we had started with superposition principle, right? Now, in superposition principle, what we have seen, we have seen that whenever we have superposition principle, you will be having multiple charges, and for multiple charges at one point, we'll have to calculate electric field. So what we'll do, we'll calculate the individual electric fields, and then we'll be adding it. Now, how will we add it? We'll add it vectorically. Why? Because these are all vector quantity. Who all are there? Mariam, Harsha, Yahya, Zaina. Sidra, Rishita haven't joined yet. All right. Let's see, they'll also join in between. So questions practicing we didn't do. We have seen a question that we have to find out the neutral point. That's our task, to find out the neutral point. Right. So how do we find out the neutral point and what is the meaning? Have the point for which your electric field will be 0, right? Or your electrostatic force will be 0. So one question, write it down. This question, just write it down. Write all the forces. Then I'll tell you. Just write all the forces. Electric field you have to calculate at the center. So see, 4 charges are present, and because of all the 4 charges that are situated, you have to find it out. All right. Because of all the 4 charges, one is plus q, one is plus 2q, one is minus q, one is minus 2q. For all the charges at the center, you have to find out the electric field. Yes, class, drawn all the field. See, we have discussed the direction of electric field. Based on that, at this point, see if you're considering plus q. See, we have to calculate the electric field at O, right? Now this is a square. plus Q, plus 2Q, minus 2Q. The calculation of electric field at the center O. When we are talking about the calculation of electric field at the center O, you have to take out the individual charges for which you are calculating. Suppose if I tell you this is plus Q, all right. Now plus Q is present and at the center O I have to calculate. So two things we studied about the direction of electric field. One was for the positive charges, other was one for the negative charges, right? So for the positive charges, what have we studied? What is the direction of electric field for a positive charge? We have studied. I gave you an example also for plus 2 coulomb and minus 2 coulomb. I told you 4 charges are 4 points we had taken. And for all the 4 points we had calculated, we had checked the direction. So what was the direction? For positive charge, is it towards or away? Yes, Harsha.
Away from the charge.
For positive, it's away from the charge. Yes, correct. So see, when we are talking about plus Q, see, if I go towards this, let me mark these points. For this is A, this is B, C, and D. So when I'm talking about plus Q, so see, for plus Q, the charges are moving away. So if the charges are moving away, then see, you have to, if I move towards it, that will be towards plus Q, right? If I move towards minus Q, that will be away from plus Q. Understood? So this will be the direction of electric field A. Electric field due to A. Clear? When we are talking about B, this charge, this is again positive. So for the positive charge, again, we'll be moving away from the charge. So when we'll move, see, if I move like this, that will be towards B, but I have to move away from B, right? I don't want to move towards B, I have to move away from B. So I'll move it this way. This is the direction opposite to it. This is electric field due to B. Right now, I'm just writing the directions of electric field. Calculation will be done through the help of vectors only. Clear class? Calculation part will be done with the help of vectors only because the electric field is what? Electric field is basically a vector quantity. So calculation of all these will be done through the help of vectors itself. Now see, coming to negative charges. So if for positive, we are moving away from the charges. So for negative, definitely we have to move towards the charge. So if we are talking about minus 2Q, O is present at the center. I have to move towards the charge now. So if I move towards C, that will be towards the charge, correct? So this means the direction will be this. Electric field due to C. Similarly, for this minus Q, if I have to move towards the charge, this will be the direction of electric field, that is ED. First, tell me, are the directions clear to all of you? Write me in the chat column if it's clear or not. Yes or no? I'll repeat it again because this is the basic step. Harsha, clear? Mariam, clear? I'll repeat. See, for positive charges, we will move away from the charge. And if we have negative point, we'll move. If we have a negative point, we move towards the charge. Correct? These are the two things that you have to remember whenever you are solving any question of electric field. Now, if plus Q is present, this is the center O. I have to write the direction of plus QE. So that means away from the charge will be in this direction. So this was EA. Correct? Now again, when we were talking about plus 2Q. EC and ED, yes. Plus 2Q is clear. Plus 2Q is again positive. So we have to move away from the charge. So this is how we got EA and EB. First, tell me all of you, direction of EA and EB is clear to all of you? Then I'll come to C and D. Yes, no, clear? EA and EB, how have we got that? All right. Come to EC. See, coming to EC and ED. We know for negative charge, if this is the point, we move towards the charge. This is the point O. Here we had minus Q, right? This. And here we had minus 2Q, right? This. OC and OD here. Minus Q and 2Q, minus 2Q. We have to move towards the charge because these are negative charges. We have to move towards the negative charge. So how will we move towards the negative charge? If I move towards, it will be like this. If I move towards this, it will be like this. Clear? So this will be ED, this will be EC. Now combine, since these two were positive, these were moving away. So we had already EB and EA. And because these are negative, so they are attracting it. So these are again moving towards it. That's why two are like this, and again two are like this. Now tell me, direction is now clear? Anyone? Clear to all of you? All right. So if the direction is clear, the calculation part is basically your vectors of class 11. So all those who do not remember vectors, this will be a revision also for you. And one thing, let me announce right now only, next class that we'll be having. See, this is Thursday, so our next class will be on Tuesday. Now on Tuesday's class, what we'll do, we'll not move further because superposition principle, electric field, Coulomb's law, questions on equilibrium, these are already quite tough topics with tough questions. So what we'll do, instead of moving further with the topic, moving further with electric field, what we'll do, we'll practice lots of questions from this till here, till electric, till superposition principle. All right, lots and lots of questions so that whatever basic minor doubts you are facing while doing the assignments, while performing after class assessment, or whatever doubts you are having regarding this, that will ultimately be clear to all of you. Clear? So practice till superposition principle and come. Because we'll be just practicing numericals and you have to be interactive in the class. You have to answer wherever doubts you will be facing. I'll be there, we'll be discussing it. All right, we'll be discussing it. So see, when we are talking about electric field, now see, our task is to find out their values. This is clear. How have we done? We have first found the direction. Now, once we know the direction, we have to find out their magnitudes. Then only we'll be able to add it or subtract it, right? So what we'll do, now we have to find out their magnitudes. What is the generalized formula of electric field class first? You know it is E is equal to K Q by R square. This is the formula of electric field. This is the formula of electric field for a point charge. It means this for this formula for this formula for this formula for this. So is there any difficulty in using this formula that we are stopping? See, K is present, K is a constant, so K is present everywhere. We don't have to find out K, right? Regarding Q, that is the charge. That is the charge Q. Q is present here, plus 2Q is present here, minus 2Q is present here, minus Q is present here. So Q is also present, so we do not have a problem in finding out Q. Correct. We have R square. See, for R square, this is the center O. We have to find out the separation of the charge with that point, right? O with that charge. O with the charge. Is the separation known? No. This is the issue. Charges are present. K is already a constant. For R square's value, we do not have the R. So how will we calculate it? Anyone who can tell me what should be the value of this? At least tell me for one, OA. What should be OA? Hint, this is A, this is A. Quickly answer in the chat column what should be OA. OA is equal to OC. That you're saying it correctly. OA is not only equal to OC, it's equal to OD also, it's equal to OB also. All the diagonals of a square, these are perpendicular bisectors of each other. So all of these are equal. That you're answering it correctly. OA is equal to OB is equal to OC is equal to OD. But I am asking what all these are equal to. Harsha, just what have you written, Harsha? Root 2 by 2 into A.
Yeah, side into root 2 by 2.
Side into root 2 by 2. So rationalize this and then tell the final answer. Rationalize it and then answer. Not A. See, Rishita. A is this. This is AB. This is A. BC. This is A. CD. This is A. AD. I'm asking this from O to A, because we have to find out the separation of plus Q from this point. Then only we'll be able to put it in the formula. So this separation, then we have this separation, then this separation, this separation. These, not A. It will not be equal to A because A is this. It's already half somewhere. So how? Harsha's answer is right. I just want Harsha you to rationalize it further. Answer is correct. Class, just focus on one thing. This is, if you look, this is a big right angle triangle. Look, like this. This side A, this side A. Isn't it a right angle triangle? With this side A, this side A. This is A point, this is B point, this is C point, right? This is the diagonal AC. Can you find out the diagonal AC? First, tell me what is the diagonal AC coming? What is the value of the diagonal AC coming? Diagonal AC will be what? This side is A, this is A. Pythagoras theorem. This is hypotenuse, perpendicular base. What would be the hypotenuse value? Yes, class. What is AC and what are
AC
the
equals to
values?
root of AB square plus BC square.
Root
Root of AB square plus BC
correct.
square.
So put the values of AB and BC. That is A only. Correct. So Rishita has at least started answering this correctly. Others, you people are not answering. If you won't be trying this, you won't get the value. See, I want you to solve this together. Then this question will be very easy because you have lots of questions. That's why I'm devoting one full class for just the practicing of numerical, so that whatever doubts you people are facing, that is clarified. See, Rishita has answered this. Under root p square plus b square is equal to h, right? H square is equal to p square plus b square. That is your Pythagoras theorem. Look class, in the triangle ABC, the diagonal AC, what is the diagonal AC equal to? Under root a square plus a square. What is this? This is 2a square under root. AC diagonal is a root 2. AD diagonal will also be a root 2. What is OA? You know from your basics, is in the of AC. If point O is in the middle of AC, or that is the diagonals half. The OA is what? OA is basically diagonals half. AC is the diagonal. So diagonals half is OA. right? So this will be a root 2 divided by 2. When you will multiply it by root 2 and divide it by root 2 to rationalize it, till here Harsha answered it. Harsha was the only one who answered it till here, a root 2 by 2. So this becomes, this is 2, 2 will be cancelled, a by root 2. Now tell me, diagonal's half is clear. How have we obtained a by root 2? In this question, I am giving a lot of time. So whatever doubts you people are facing right now, answer. This is clear. How have we obtained a by root 2?
Yes, ma'am.
Zaina, it's getting clear, everything?
Yes, ma'am.
Okay. So you all now know that this is a by root 2. Means what do you all know now? That the separation of charge to O, this is a by root 2. This side is also a by root 2. This side OC is also a by root 2. And OD is also a by root 2. That means this answer, all these were equal to a by root 2. Fine. Now, first let us write down the individual values of electric fields. We'll solve it later on. We'll solve it later on how to find out the net electric field. Because what have we studied in superposition principle? We have studied in superposition principle that you have to find out the individual electric fields first. See, 4 charges are present and we have to find out the net charge at the center. So according to superposition principle, you have to find out the individual electric fields first. All right. Once you will find out the net electric, once you will find out the individual electric fields, then for the net electric field, we'll use the superposition principle, that is the vectors. But right now, what is the first step of superposition principle? To find out the individual. So let us write down what is EA, what is EB, what is EC, what is ED, right? See, the second half of the question, this is the first half. This is how you have to begin all your questions. Triangle will be given, pentagon is given, different figures are given, triangle, pentagon, all the different figures. So you have to be careful with it. The same steps are repeated. All right, now look. EA, when let's talk about two values together. EA and EB will be solved together. EC and ED will be solved together, right? So let us write down the values of all. What is EA? See, again, I'm telling you the formula is KQ by R square. Electric field is KQ by R square. This is the formula. E is equal to KQ by R square. Look at the figure. A points charge, point O, their separation. So how will we write it? K. I am telling this question, so be careful right now. This is K. What is the charge? Charge is
Small
plus.
q.
Yes.
Small q.
And separation is a by root 2. So that becomes a by root 2 whole square. So root 2 into root 2 will be 2, right? And that will go up. So that will become 2 KQ by a square. This is EA. Come to EB. What is the charge here? 2Q. Rest everything is same. So K into 2Q divided by, separation is same in all, right? A by root 2 whole square. Now see, when the 2 will go up to multiply, this 2 is already present. So 2 into 2 will become 4. So 4 KQ by A square. EB. EC. EC has minus 2Q. So again, we take the magnitude only. So this will be 2Q by A by root 2 whole square. This will also be equal to 4 KQ by A square. And then we have ED, which is also equal to Q. So this is ED. This is equal to K into Q divided by A by root 2 whole square. So this is equal to 2kq divided by a square. Fine. All these magnitudes we have written. So individual electric fields are present. Now, what is the superposition principle? Superposition principle says that individual electric fields are calculated and then their resultant is calculated by adding all these vectorically to get at the point, right? This is the task to find out. So here in this question, EB and EA are present in different directions. ED and in both the arms, this V-shaped arm that is formed. In both these arms, two vectors are present. So at least let us solve these two vectors first. We can add them. Both the vectors are in the same direction, so you can add them. If two vectors are in the same direction, you directly add them, right? So these two can be added. These two can be added to get the resultant of each arm first. I am telling you it here. This is B, E, C. Resultant first, that is E1 of this arm. And then we have to find out this resultant, that is E2 of the arm. Then we'll be left with E1 and E2 that we can solve. Why are we following this step? Why are we following this step? Why aren't we directly finding out the resultant? Because individual electric fields have been found. Why are we solving it in this manner? Reason is that electric fields or any vector, parallelogram law uses only two vectors. Parallelogram law of addition uses only two vectors. Here, how many vectors are present? 1, 2, 3, 4. So we have to solve these two vectors first and get our first vector. Then we'll solve these two and get our second vector. Then these can be solved through the help of parallelogram law. So EB plus ED. Let's add them. Let's get E1 first. E1 will be EB plus ED. What is EB? EB is 4kq by a square, ED is 2. So this becomes 4kq by a square plus 2kq by a square. So when you add, this becomes 6kq by a square. This is electric field first, means we have solved this arm. We have E1. Here, which arm is this? This arm. OD is having net electric field as 6kq by a square, correct? This arm has 6kq by a square. Similarly, EA plus EC, what is EA? 2kq by a square. What is EC? 4kq by a square. So when you add E2, that is EC plus EC and EA. So this is again 4kq by a square plus 2kq by a square. So this is equal to 6kq by a square. You have both the electric fields present. E1, E2 both are present. Look at the figure. This side is E1, this arm is E1, this arm is E2. Can anyone tell me for parallelogram law, I need angle. What is the angle between the vector E1 and E2? That is this arm and this arm, because I have to use parallelogram law. For parallelogram law, yeah, you're answering.
Yes, ma'am. I have a doubt. In the question, it says that EC is minus 2 ohm. So we have.
Harsha is right. Yes, yeah.
I have a doubt.
See, I have told it in the class also. For square, both the diagonals are perpendicular bisectors of each other. That is, they equally divide the diagonals into two halves making 90-degree angle between them. This angle is 90 degree automatically. All these angles are 90 degree of a square at the center made by the perpendiculars diagonals. All right. So it means both the vectors are present. This angle is 90 degree between them. So how will we find the resultant? Resultant or net electric field will be under root E1 square plus E2 square. So both the vectors are same. That is, you can replace it as 2 E1 square under root. This can be replaced at 2 E1 under root. So E1 can be taken out common. Root 2 is left. What is the value of E1? 6 k cube by a square into root 2. This is the net resultant electric field. So root 2, 6 root 2 k cube by a square. See, this is the resultant that we are getting. 6 root 2 k cube by a square. Because both the vectors are making an angle of 90 degrees. See, how do we solve the perpendicular vectors? Why have we just used this? Reason is that vectors are, resultant says under root a square plus b square plus 2ab cos theta. If theta is 90 degree, cos 90 degree becomes 0. Means this term becomes 0. So we are only left with under root a square plus b square whenever we are calculating the resultant. Yes, Mariam?
Ma'am, can you hear me?
Yes, Mariam, say. Yes, Mariam, say.
Shouldn't EC be minus 4Q by A square? Because in the question it's minus
See,
2Q.
I have told you this multiple times. Whenever you are using electric field is derived from Coulomb's law. The derivation that we did, that derivation was done through the help of Coulomb's law only, right? What is the first statement of Coulomb's law? Coulomb's law basically says that the force is directly proportional to magnitude of charges. So here you will only take the magnitude of charge. You will not take the sign, whether it's minus plus. In the last class also Harsha asked the same doubt I told. See, negative, positive, whatever type of charge is present, you have to focus on the magnitude. Minus 2q plus 2q, you just make sure that you are taking 2q. Clear?
Okay, ma'am.
Now this answer is clear. How have we obtained 6 root 2 kq by a square?
Yes, ma'am.
Others also, apart from Yahya?
Yes, ma'am.
Rishita, Zaina, clear? All right. Write it down. Write down the solution. Yes, class. What's the answer coming of the resultant force?
Ma'am, I got for FBA I got 180N, and for FAC I got minus 180N. But I'm confused on what to do next.
See, that is right, but how will you get minus? Have you taken only the magnitude?
Yes, I calculated with F is equals to
Oh,
KQ1
okay, let
Q2.
me discuss. And see, half that value is correct. It's just that you won't get minus right now without the direction. Minus sign is for the direction. See, let me draw it first. See, we have to find out the resultant force. This is the question based on force, not the electric field. So we have to find out at A. So see, at A, so how many more charges are present? Two more charges are present. So when we are finding out the electric field, electric force at A due to B, what will happen? Plus 5, this is plus 10, both are positive. So plus 5 will be repelled. This is force, not electric field, this is force. This is F1 or this is due to B. I'm just writing F1. Again, now this is minus 10, this is plus 5. So plus 5 will be moving towards C because this will be attracting it. Plus, this is an equilateral triangle. So look, if this angle is here, this is forming 60 degree and total is 180 degree. So what is the angle that is formed here? 120 degree. So what type of parallelogram? Now this is an easier question than the previous one. This is F1. This is F2 with an angle theta which is 120 degree between them. Parallelogram law you can use, but before you use the parallelogram law, I think it's better if you find out the magnitude, F1, F2 both. So 180 Newton if you're getting, that is correct, but minus 180 isn't correct. See, F is equal to K1 into K is equal, F1 is equal to K, Q1, Q2 by R square. So 9 into 10 to the power 9. What is the first charge? A. That is 5 microcoulomb. What? This is 5 into 10 to the power minus into 10 microcoulomb. 10 into 10 to the power minus divided by, what is the separation? 5 centimeter, no?
Yes, ma'am.
All these are separated by 5 centimeters. So this becomes 5 into 10 to the power minus 2. 5 cancelled. 5. This will be square, r square, no? So 1 5 will be remaining. So 1 5 will be there, 10 to the power minus 2. So this will be 180 Newton. But the direction will be towards, what is this direction? From B to A, that is towards BA. If the direction of force was this, we would have written the direction as AB. If the direction is this, we'll write towards BA. Fine. This is F1. Coming to F2, that is plus 5 and minus 10. See, we'll just take the magnitude. So both will come same. K, Q1, Q2 by R square. This is 9 into 10 to the power 9. Q is 5 into 10 to the power minus 6. Minus 10 we won't take. We'll take it as 10 into 10 to the power minus 6 only, because we take the magnitude. So 5 into 10 to the power minus 2 whole square. Again, this will be 180 Newton. It's just that the direction is towards AC. That is this way. This is A, this is C. So AC. From AC, this is towards AC. So parallelogram law, F net, this is equal to F1 square plus F2 square, or actually both the values are same. Let's just write them as F. Why to write them as F1, F2 when both the values are same? F square plus 2F into F into cos 120 degree. This is 2F square plus, this is 2F square into minus half under root. So this 2 will cancel. So this will be 2F square minus F square under root, which is equal to F, that is equal to 180 Newton. So the resultant force is also equal to 180 Newton. When you have to find out for the direction, that will be tan beta is equal to B sin theta divided by A plus B cos theta. Please revise your vectors and come all those who are forgetting this. You must have done it earlier. So this is sine, that will become root 3 by 2. A is 180
Ma'am, we
plus
don't have to
180
find direction in
into,
the previous question.
yes,
Ma'am, we don't have to find direction in the previous question.
here.
Yes, ma'am.
Here also you have to find out the direction. This is just the magnitude. Here also you have to find out the direction. Same method. It's just that this is 90 degrees, so this is easier to find out. Just divide both the vectors.
Okay.
Here, see, reason is that in this arm you are getting 6kq by a square. Here you are getting 6kq by a square. So when you have solved them, their resultant is somewhere here, right? That direction you will take it as beta. So angle with which this is made, that is taken as A, and other one is taken as B. Here also you have to find. Here, this is just one question that I'm telling you. Rest of the question you all have to find the direction. So how much will it be? 90? 3. I think this is around 60 degree. Just check it once. I have not calculated it. This is 60 degree. So it's like this is force 1, this is force 2, this is the resultant that we are getting 180 degree. This is beta that we have taken. So that's why this has become A and this has become B using this formula. Write it.
Ma'am, F1 is away from AB, right?
F1 is?
Away from AB, right? The direction.
F1 is away from AB, so it's towards B. When we write towards AB means towards AB, that is take point A, go towards B, like this. So that's why I've written towards BA. Towards BA means this direction. That is from B to A. In exam also, you have to write the direction while you are calculating in between like this only, towards AB. Or you can write along BA. Instead of writing towards B, you can write along BA or along AB. That will be fine.
Yes, ma'am.
If you all have completed, you can leave. In the next class, we will practice the numericals only. So please practice and come the questions that we have done. Till here, we will be practicing. So Coulomb's law, everything from the starting will come. All right. So you can leave now. Thank you so much, class. Bye-bye.
Okay, ma'am. Thank you.
Ma'am, I have a doubt in a question. Can I send that?
Yes, Harsha.
I have a doubt in a question. Can I send that?
Yes, send it. Okay, so 1.5 says 3 charges are present at the vertices of equilateral triangle. What is the force on the charge q placed at the centroid? So see, F1 will be away, F2 and F3 will be, answer should be 0. See, F1, if you will calculate, F1 is downwards. Look, F1 is downwards because it's away from this charge. Then F2 is away from this plus q, so it is in this direction. And if F3 is away from this charge, it is in this direction. So first, what will you do? Because vectors add only, a parallelogram law uses only 2 vectors, so you will solve them. When you will solve them, the resultant will be in this direction. That is the F32's resultant. Then take this. If the values are same, if the values are coming same, then answer will directly be 0 because both of them will be cancelling each other. If the values are different, then these are 2 vectors with the angle 180 degree between them. Clear?
Yes, ma'am.
Next question, what is the force on each charge? Means F1, F3, you have to find, consider the charges Q, Q and minus Q placed at the vertices of an equilateral triangle as shown in figure 1.7. What is the force on each charge? Means Q we have to find out. That is F2. See, this is a very lengthy question. This is suppose Q. One I'm telling, rest of that you will be able to solve. One charge is here, one charge is here. So due to this, one force is directed, suppose this force is directed like this, and due to this is directed like this. So you have one vector as this force due to 1, and due to 2, you have this force as 2. Then their resultant you will take, see, it's an equilateral triangle. So this is 60, again the angle is 120 degree. You will find out the resultant force the way we have found. Then again you will take this charge. Due to this is moving towards. Due to this is moving towards. The angle between them is 60 degree. This is one vector here, F1. This is one vector here, F2. You will solve. Similarly, here also this, like this. 120 degree angle between them. You will solve the vectors. Clear?